When we search for alien life, we usually look outward, farther, brighter, newer, young stars, fresh planets, new beginnings. But the universe doesn't work on human timelines. Some stars have been burning for billions of years longer than our Sunday. They formed when the universe was younger, quieter, and filled with raw material. Around those stars, planets had a head start, not millions of years, but billions. If life is slow, if intelligence takes time, if civilizations need long periods of stability to emerge, then youth may be at disadvantage. Older stars have watched galaxies form and evolve. They've seen planets cool, atmospheres settle, chemistry repeat endlessly. If alien life needs patience, time, and repetition, then the most likely places to find it may not be near stars like ours. They may be near stars that have been shining since long before Earth existed. Stars that are old enough for life to experiment, fail, adapt, and possibly succeed. So the question isn't just where to look for aliens. It's how long the universe has been giving them a chance. Once a star forms, a clock begins. Not a human clock, but a cosmic one. Life, if it appears at all, has to work within that time. On Earth, it took billions of years for simple chemistry to become biology, and billions more for intelligence to emerge. That process wasn't fast. It depended on stability, repetition, and long periods without total reset. Older stars offer exactly that. Stars that formed earlier in the universe have existed for far longer than our Sunday. Their planets have had more time to cool, to develop atmospheres, and to allow chemistry to run its course again and again. Every extra billion years is another opportunity for life to begin, fail, adapt, and try again. Time matters because evolution is slow. It is driven by small changes accumulating over immense spans. Around younger stars, life may still be at an early stage, simple, fragile, unfinished. Around older stars, life has had far more chances to move beyond simplicity. This doesn't guarantee intelligence. Nothing does. But it shifts the odds. Older stars give life more time to experiment with complexity, more time to build ecosystems, more time to survive planetary changes without being erased. If intelligence is rare, it may not be because the universe lacks life, but because it lacks time. And older stars are where the universe has been most patient. That patience may be the most important ingredient of all. Time alone is not enough for life to evolve. It also needs stability. Planets must remain in predictable orbits. Climates must avoid constant extremes. Catastrophic events must be rare enough for life to recover. Older stars are more likely to provide that kind of environment. In the early life of a star system, chaos is common. Planets migrate, collide, and settle into place. Asteroids are abundant. Orbits shift. Impacts are frequent. It's a violent period, hostile to long-term biological development. But over billions of years, that chaos diminishes. Around older stars, planetary systems have often already survived their most unstable phases. Orbits have stabilized, major collisions are less frequent, debris has been cleared or locked into predictable paths. This creates a quieter cosmic neighborhood, one where life has a better chance of persisting without being repeatedly erased. Stability also allows atmospheres to remain intact. It lets oceans, land, and climates settle into long-term patterns. Without that consistency, evolution struggles to move beyond simple survival. Older stars don't guarantee safety. Nothing in the universe does. But they are more likely to host planetary systems that have already passed the most destructive stages of their history. And for life surviving long enough is just as important as starting at all. A stable system gives evolution something rare in the universe, time without constant interruption. That may be why older stars are among the most promising places to look for alien life. Stability and time together create a final possibility advancement. Some stars don't just last billions of years, they last tens or even hundreds of billions. These long-lived stars burn slowly and steadily, providing energy over timescales far beyond the lifespan of stars like our Sunday. For any alien civilization, longevity matters. Technology, intelligence, and complex societies don't appear instantly. They require extended periods without total collapse. They require generations of accumulated knowledge, repeated problem solving, and the ability to recover from mistakes. Around long-lived stars, life doesn't face an early deadline. Civilizations aren't racing against a star that will expand or destabilizes planets too quickly. They have time to experiment, to fail, to rebuild, and to advance. This also means something else. If advanced alien civilizations exist, they may not be young, they may be extremely old. Their technology could be subtle, efficient, and quiet, optimized over immense spans of time rather than explosive growth. That could explain why we don't easily detect them. Not because they aren't there, but because they've had time to outgrow obvious signals. Long-lived stars don't guarantee advanced civilizations, but they offer the one resource intelligence needs more than anything else: time. And in a universe measured in billions of years, time may be the difference between simple life and something far more advanced.